Have you ever gazed upon a star-strewn night sky and wondered, where did it all begin? The universe whispers tales of creation, of cosmic fire, and the silent, eternal dance of celestial objects. Among them, stars shine brightly, beacons in the vast cosmic ocean. But where do these dazzling points of light come from? Let's embark on a journey to unravel the mystery of stellar birth, a story as old as time itself. Our story begins in the cold, dark depths of space, within colossal clouds of gas and dust known as nebulae. These vast, seemingly empty regions are actually teeming with the raw materials needed to create new stars. Nebulae are often the remnants of previous stellar generations, the cosmic wombs from which stars are born. They are the nurseries of the universe where the cycle of stellar life begins anew. These nebulae, often remnants of previous stellar generations, are the cosmic wombs from which stars are born. Within these stellar nurseries, the delicate balance of forces begins to shift. Gravity, the master sculptor of the cosmos, draws these scattered particles together. Over time, these particles coalesce, forming denser regions within the nebula. Gravity, the master sculptor of the cosmos, draws these scattered particles together. Slowly at first, then with increasing speed, the cloud collapses under its own weight. This process is not instantaneous, it can take millions of years for a star to form. As the cloud contracts, it heats up, glowing with an eerie, ethereal light. This light is a sign that the cloud is becoming denser and hotter, a prelude to the birth of a star. Slowly at first, then with increasing speed, the cloud collapses under its own weight. The particles within the cloud are drawn closer and closer together, increasing the pressure and temperature at the core. This process, much like a cosmic dance, culminates in the heart of the collapsing cloud, reaching temperatures high enough to ignite nuclear fusion. As the cloud contracts, it heats up, glowing with an eerie, ethereal light. This glow is the result of the intense heat generated by the collapsing cloud. At the core, temperatures soar to millions of degrees, creating the perfect conditions for nuclear fusion to begin. This is the moment when a star is truly born. This process, much like a cosmic dance, culminates in the heart of the collapsing cloud, reaching temperatures high enough to ignite nuclear fusion. Hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure and heat. This fusion process releases an unimaginable amount of energy, which radiates outward, illuminating the surrounding space. Hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure and heat. They fuse, releasing an unimaginable amount of energy and giving birth to a star. This energy is what makes stars shine so brightly, and it is the same energy that will sustain the star for millions or even billions of years. They fuse, releasing an unimaginable amount of energy and giving birth to a star. Imagine, if you will, a giant cosmic sneeze. That's essentially what happens when a star is born. A sneeze of epic proportions that sends shockwaves through the universe. These shockwaves can trigger the formation of new stars in nearby regions, continuing the cycle of stellar birth and death. Imagine, if you will, a giant cosmic sneeze. That's essentially what happens when a star is born. A sneeze of epic proportions that sends shockwaves through the universe. These shockwaves ripple through the surrounding nebula, compressing gas and dust and potentially triggering the formation of new stars. It's a beautiful, interconnected process that ensures the universe is always teeming with new life. That's essentially what happens when a star is born. A sneeze of epic proportions that sends shockwaves through the universe. These shockwaves can travel vast distances, influencing the formation of new stars and shaping the structure of galaxies. The birth of a star is not just the beginning of a new celestial body, but a catalyst for the ongoing evolution of the cosmos. Once a star ignites, it enters a phase of relative stability known as the main sequence. During this stage, the star exists in a delicate balancing act. Gravity constantly tries to pull the star's material inward, while the outward pressure from nuclear fusion pushes back. It's a cosmic tug-of-war, and for millions or even billions of years, the star maintains this equilibrium. Think of it like a teenager going through a growth spurt, a bit unstable, full of energy, and constantly burning through its fuel. Stars, much like teenagers, come in different sizes. Smaller stars are like the quiet kids in the back of the class. They sip their fuel slowly and live long lives. Massive stars, on the other hand, are the life of the party, burning brightly and exhausting their fuel reserves much faster. Grand finales, when stars exit the stage. The universe is a grand theater, and stars are its most dazzling performers. But like all great shows, even the most brilliant stars must eventually take their final bow. But even the most energetic stars eventually run out of fuel. This process is inevitable, a cosmic certainty that marks the end of a star's life cycle. As they exhaust their nuclear fuel, their fates diverge based on their mass and composition. What happens next depends on the star's mass. The mass of a star determines its entire life story, from its birth in a stellar nursery to its ultimate demise. Stars come in a variety of masses, and this diversity leads to a range of spectacular endings. Low-mass stars like our own sun will eventually puff up into red giants, shedding their outer layers into space. This transformation is a dramatic one, as the star swells to many times its original size, engulfing nearby planets in its fiery embrace. These layers form beautiful glowing clouds of gas and dust known as planetary nebulae. These nebulae are some of the most stunning objects in the night sky, their vibrant colors and intricate shapes a testament to the star's final act. The remaining core of the star shrinks and cools, becoming a white dwarf, a stellar ember slowly fading into oblivion. White dwarfs are incredibly dense, with a mass comparable to the sun's but packed into a volume similar to Earth's. High-mass stars, on the other hand, go out with a bang, literally. These stars live fast and die young, burning through their fuel at a much quicker rate than their lower-mass counterparts. When these stellar giants exhaust their fuel, they collapse in on themselves, triggering a supernova, one of the most powerful explosions in the universe. The energy released in a supernova can briefly outshine an entire galaxy, making it visible across vast cosmic distances. These events are so bright that they can outshine entire galaxies for a brief period. The light from a supernova can travel across the universe, reaching us here on Earth and providing a glimpse into these cataclysmic events. The remnants of this cosmic cataclysm can form either a neutron star, an incredibly dense ball of neutrons, or a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Neutron stars are the densest objects in the universe, while black holes represent the ultimate gravitational collapse. Stellar surprises, fun facts from the cosmos. Now that we've explored the life cycle of stars, let's delve into some fun facts about these celestial powerhouses. Did you know that the largest known star, UY Scuti, is so massive that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter? Talk about a cosmic heavyweight. And here's another one. Stars twinkle because of Earth's atmosphere. As starlight passes through the different layers of our atmosphere, it gets bent and scattered, causing the twinkling effect we see from the ground. It's like looking up at the stars through a giant, constantly moving swimming pool. Our cosmic connection, children of the stars. As we conclude our journey through the lives and deaths of stars, it's important to remember that we are all connected to these celestial objects in a very profound way. The stars are not just distant points of light in the night sky, they are the very essence of our existence. They are the cosmic forges where the elements that make up everything we know are created, from the smallest grain of sand to the vast oceans, from the air we breathe to the complex structures of our bodies. Everything has its origins in the stars. The elements that make up our bodies, the air we breathe, the water that sustains life, and the very ground we walk on. They were all forged in the fiery hearts of stars billions of years ago. These elements were scattered across the universe when stars exploded in supernovae, seeding new star systems and planets with the building blocks of life, the very ground we walk on. They were all forged in the fiery hearts of stars billions of years ago. This cosmic connection is a reminder of our place in the universe, a testament to the incredible processes that have shaped our existence. It's a humbling thought, but also an empowering one. We are quite literally children of the stars. We are quite literally children of the stars. This realization can change the way we see ourselves and our place in the cosmos. It can inspire us to look beyond our daily lives and consider the bigger picture, to appreciate the beauty and complexity of the universe. So the next time you gaze up at the night sky, take a moment to appreciate the awe-inspiring beauty of these celestial objects. Think about the incredible journey that the light from those stars has taken to reach your eyes, traveling across vast distances and through the fabric of space-time. They tell a story of creation, of life, and of the interconnectedness of everything in the universe. Each star is a chapter in the grand narrative of the cosmos, a story that we are all a part of. By understanding this story, we can gain a deeper appreciation for the universe and our place within it. And remember, within each of us lies a spark of that same cosmic fire that ignites the stars. This spark is a symbol of our potential, a reminder that we are capable of great things. Just as stars can create new elements and new worlds, we too have the power to create, to innovate, and to make a difference in the world. We are all made of star stuff, and our potential, like the universe itself, is limitless. Embrace this cosmic connection and let it inspire you to reach for the stars in all that you do. The universe is vast and full of wonders, and we are an integral part of it. So as you look up at the night sky, remember that you are a child of the stars and your potential is as boundless as the cosmos itself.